Welcome to Math 150, multivariable calculus. Let's see. All right, so the purpose of this class is, not surprisingly, to teach you multivariable calculus. This is going to build on single variable calculus. And so the question people always ask is, how much of one variable calculus do you need to remember? So I love to encourage class participation for a variety of reasons. This is especially important when we have a Zoom setting like this. There is a tendency, and I was the same way when I was a student, not to speak up, to be afraid to say anything in class. And so I give extra credit for comments. And so if you make a good comment in class, just email me afterwards. There's several reasons for this. One is it helps me get to know you. And so the more comments you say, the more emails we exchange back and forth, the better I know you. Two, you might not realize at the time what's a good comment. Oftentimes, something that might not seem that important is actually a really good observation. The third, and probably the most important, is this gets you into good habits for later in life. You want to be noticed. You want people to know who you are. When I was young, I was an introvert. I could not speak in class. I felt terrible going to any professor and asking for help or asking to talk. I felt I was wasting their time. And I lost many opportunities because of this. The class is deliberately designed like this to try to give you tremendous freedom to control what we do. If there are things you want me to cover, you can let me know either live in class or you can email me beforehand. Previous years, people have had me incorporate everything from bees to the gastrointestinal system into multivariable calculus. And so I'm always up for a challenge. If there's something that you're interested in, let me know, and hopefully we can find a way to make it come into the class. But if you get in the habit of speaking up now, it will be easier later in life. And so for me, I didn't really speak up until grad school, when one of my friends told me I should be a social chair. And I was hesitant at first because normally for a social chair, you envision somebody who likes people, likes being with people. That was not me. And it was one of the two best things that happened to me in grad school. It was up there with the mentoring I got, is it really got me out of my shell. So the more times you speak, the better it's going to be. Is there anybody here who is thinking of being a professional mime? I won't ask you to say anything. If so, just raise your hand. Okay, so I see no hands up, so no one is planning on a career in mime, which means almost surely you're going to have to talk to people at some point in your life. And so a huge part of this class is building up skills that you can use in almost anything. And so I used to tell my students, if you knew probability, statistics, and programming, you could always have a job. You may not like it, but you will always have a job. I can't say this because somebody sued her school when she graduated without a job. And she found a new type of discrimination, GPA discrimination, that the school did more for students with higher GPAs than lower GPAs. If you know probability, stats, and statistics, you will almost surely be able to get a job. But those aren't the only skills to know, and there's a reason this is not the Williams Institute of Technology. This is Williams College, where you have professors who are here because we want to interact with students. You are strongly encouraged to take advantage of classes across the spectrum. So even if you want to just be a scientist, if you want to go up to graduate school in math or physics or something like that, you still need to be able to speak. You need to be able to write. And so I strongly encourage you to explore throughout the divisions at Williams. These are going to be skills that will serve you valuably in the years to come. We are the only department on campus to still require a public speaking assignment to graduates. All of our math stats majors have to give a technical talk. And it is an absolutely wonderful skill to learn. So I really want you to work on that in this course. If you are not comfortable, absolutely fine to email me beforehand or to send something in a chat or to just have somebody else ask the question, that's fine. This is actually one of the nice things about Zoom is it's very easy to send something to just me. I will try to be monitoring it so you don't have, Professor Miller, I just sent you a secret chat. I will try to be watching for things so I will have multiple devices so I can hopefully see that. But I cannot promise to be perfect. But again, you can email me before class about things you want. So over here it says homework 15%, midterms there'll be at least 2 or 3, 40%, final 45%. I will drop your lowest midterm unless you tell me otherwise. I will assume everybody wants their lowest midterm dropped. So the first midterm you should really view as a diagnostic. I will also give you a 92.5, which is right on the boundary of an A or A minus for 60% of your grade, and then just reskill everything else accordingly if you come to class prepared. This means you have watched the video. It does not mean that if I am put into isolation because of COVID or for some other reason that you can give the lecture, but it means that you are coming to class having listened to the video, you know what was being discussed, you've read the book, you are ready. We have less time in a semester at Williams than you have in a semester in high school, and we have a lot more material to cover. There's ways to do this. One way is to go very rapidly. Another is to use our time productively. And if there are things which most of you can pick up on your own, then it's much better for you to do that and give a better use of the class. Now, of course, if there are things that you have questions about, I'm always happy to chat. We have 4 TAs for the class. That is a tremendous ratio of TAs to students. We also have the Math Stats Science Resource Center. And I will try to arrange it so that hopefully at least once, if not twice a day, there's always going to be a student who's available for questions, either on the material we're doing or on prerequisite material. Feel free to send me an email. In previous years, I used to say that you can't find a 3-hour window from 9 p.m. to 7 a.m. when I will not respond. I am getting older. I don't know if I can still do that 3-hour window, but you are welcome to see if you can find one where I fail. We want you to succeed in this class. We want the resources to be there for you. So if there are things that you want us to discuss, let me know. I really want to highlight the applications of the class. We will do some mathematical modeling. We will do an introduction to statistics. We will see how you can use this material so that at the end of your semester, you will actually know enough to be useful for various things. If you are interested in working in some applications, I have a lot of consulting opportunities or research projects, always happy to talk and see if one of them is applicable for you. Along these lines, always happy to try to get to know people. I try to tell my advisees and my students, you want to get to know at least one professor well each semester. I am happy if I am one of those professors. I'm happy if it's someone else as well. But this way, if you are only successful half the time, by the time you graduate, you will have 3 or 4 professors who know you, who will be aware of what opportunities to shift your way, who can write letters of recommendation for you. I will try to connect you to alums as well. These are also absolutely wonderful resource. But anyways, for the course mechanics, 60% is going to be right on the boundary of an A minus if you just come to class prepared. Speak up in class, and when you make a good comment, just shoot me an email. And again, I'm trying to, as much as possible, minimize grade stress in something like this. Most of you are not going to use most of this material ever in your life. What you will use is the techniques of how to attack problems. Problem solving is extremely valuable. In the last class, somebody asked, is this an innate skill? Is it something that is developed, or is it a mix? And I would say it's more of a mix. You will find that I love cultural references from the 1980s, as well as whatever's current with my kids who are 6th and 8th grade. That means there is unfortunately a little bit of a gap between my cultural references and you. It's hopefully not so bad because my kids are at least 6th and 8th grade. I know one of the neighborhoods had a contest where you could win some prizes, and there were 2 online games that were being played. I think it was Among Us and Scribble.io, which happened to be 2 of the games my kids know, so that there is a non-trivial overlap. If there are cultural references you want, try to let me know, and I'm happy to try to work them in. I'm big on Seinfeld and The Simpsons, but those I know are not as popular these days. Anybody a fan of Young Sheldon? Or The Big Bang? So my kids and I were watching an episode of Young Sheldon. The main character, Sheldon, becomes a Nobel Prize winning physicist who has no idea of how to interact with normal people. And he is a genius, but he's a genius with some issues. And in the episode we watched, his older brother, who is usually considered a screw up, turns out he's a genius in automotive repairs, and he can just find, for instance, where a tire is leaking. We all have different skill sets, and there are some things that can be developed, and my job is to help you develop those skills. So if you say, I'm not good at this, you're not good at this yet. It is a process, and you get better with practice, and you start to learn how to look at things. And there are techniques that you can do to learn how to do algebra better. So one of my favorite examples is, first question, who can give me the sum first? If the pen works, that is. So the pen is not working right now. Wonderful, okay. Again. All right, so let's try this. And I did test this right before class began, and it was working right before class began, and now it is not working. Wonderful. Try one last time. And this is the joys of technology and why I wanted to actually lecture in the classroom, which is locked right now. Okay, so let's see. Nope. All right, I will do it the old-fashioned way. All right. So what does this sum equal? So what would this sum equal?
$24,600.
Okay, how did you get that?
Just cancel the numbers that appear for twice. And
excellent. So we have the 2 and a negative 2, they cancel. An 11 and a negative 11, they cancel. A 117 and a negative 117, they cancel. A 368 and a negative 368, they cancel. And so if you look at this the right way, you actually don't have to do all those intervening steps. You just have to do 24601 minus 1. For cultural extra credit, who has the number 24601?
Jean Valjean.
Jean Valjean, excellent. So when I was a graduate student, you had to demonstrate proficiency in 2 out of French, German, and Russian. So I knew Spanish, so mathematical French wasn't too bad, but for the German, that was very hard for me. And so one of the things I did is I actually did read Les Miserables in French and German, or at least parts of it, to just get some familiarity with some of the words. Also, it was very interesting seeing how things change from translation to translation. So a lot of math is about trying to find the right way to look at things. So I am a huge fan of Rubik's Cubes. Has everyone seen a Rubik's Cube? So if you want, it takes about an hour to learn how to do a 2x2 Rubik's Cube. I am happy to have events where I teach you and your friends. You get to keep the Rubik's Cube for free. It's a wonderful skill to learn. How many sides does a cube have? 6. Is it clear that this is the red side and it just turns? Okay. This is also a Rubik's Cube. It's a little bit different. If you look at this, well, okay, maybe it looks kind of similar. It's a little bit of a cross pattern, okay. But when I get to the red, instead of being 3x3, it's now 2x3. And if you try to turn the red side, the red side just doesn't turn. And so the question is, how do you solve a cube like this? And if you think that this is hard, I actually originally got this cube when I was visiting my daughter's 3rd grade class, and they had a cube like this, except all the sides were the same color as well, and they were different sizes. And so when you have a cube like this, as you start to turn it, you see it actually starts to explode and is no longer confined to a cube shape. It turns out that these 3 cubes are all the same. The gold cube, mirror cube, and this cube, they're the easiest to see that they're the same. Instead of using color, I'm just using size. It's much easier for me to do things with color than with size, but it's the exact same algorithms. For this one, it's a little bit harder to see that it's the same, And I wasn't able to see it initially. I had to go to bed, slept on it, and then the next morning, and oh, this is what you do. And sometimes when you're tired, you don't necessarily think with the same thought processes, and you're more likely to see easy things. So strongly urge you, if something is just bothering you, put it on hold, come back to it after a while. So the way to see that this is the same is you hold it at a 60-degree angle, 30-degree angle. And now, if I rotate this, hopefully you can see this, this side rotates as a normal side of a Rubik's Cube. And so I can use the exact same algorithms as before if I just remember to hold it at 30 degrees. And now the red side is not just this red side over here, it's also including this little bit of blue as well. This is one of the big themes of the class, is how do you look at algebra so that you can find the right way to do it. My main mentor at Yale was a physics professor who did groundbreaking work in experimental nuclear physics in the 1950s. He was evacuated from London during World War II during the bombings. And when he went to school, they didn't have calculators, they didn't have the internet, they didn't have computers. When he learned trigonometry, he learned trigonometry. He knew cosine and sine up to 10 theta. He knew all those identities by heart. And he said that oftentimes when he was doing physics, it was very valuable that he could just look at things and just see how they simplified and saw what was going on. I want to help you find ways to go through the tedious algebra and see the big picture of what's going on, how to view things, how to look at things. Okay, so again, you're going to forget most of what you learn in this class unless you're using it, but the hope is that one day you'll go, wait a minute, he was babbling about something that I think might be related to this. Let me check the notes from the lectures, all the notes are online. Let me check the video, all the videos are online. Ah, it's Lagrange multipliers, okay. We have less time than you have in high school to do more material. And for those of you who go into physics or chemistry, you're going to want to see Green's theorem, Gauss's theorem, Stokes' theorem. For those of you who are going into economics, you're going to want to see Lagrange multipliers. And the only way to cover all of this is to use our class time efficiently. I have never gotten a job because I know more facts than someone else. I've gotten a job because of the ways that I can communicate with people and make connections. So we talked about speaking up and getting comfortable speaking with people. When I was applying for the job at Williams, I was recruited by a big firm in New York City, and I did everything wrong for interviewing with them because I really didn't want to leave academia. And for those of you, if any of you have job interviews, I'm happy to give you mock interviews and give you advice on how to do them. I forgot to share this story with section 1, so I'll share this with you. If a big firm says that you are high on their list and that they would like to interview and that they will see you at 8:30 a.m. at their headquarters, the correct response is not, oh, I'm not a morning person, let's meet in the afternoon. One would think it would be obvious not to respond like that, but given that a Williams student did do that a few years ago and not only lost the job, they lost the ability of this professor to recommend anyone to this company, I will just share that story. So I am having a job interview at this firm in New York, and they tell me that lunch is not part of the interview. You're just going to have your lunch with somebody from human resources and just find out a little bit more about the company. What does it mean when somebody tells you it's not part of the interview?
It's part of the interview.
But they said the interview, right? I would still assume that it is part of the interview. And so I had a very nice lunch with her, and it turns out she was a graduate of Williams College and was an art history major. I am a cultural Philistine, but for 15 minutes to an hour, I can fake it on almost any subject. And so you will see later this semester applications of multivariable calculus to art. And because I had actually seen some of the stuff in museums, we had a non-trivial conversation. I was one of only 2 people she ever remembered. I did get the job offer, but I also got the offer from Williams, and it was a no-brainer to come here. Years later, she leaves the firm and she starts her own company, finding jobs for people, placing people. And she reaches out to me because she knows I'm a Williams professor. We've kept in touch. And she helps connect Williams students with opportunities, with former Williams students who are clients of hers, including somebody high up in NBA analytics, who came to Williams, gave some talks and mentored some of our students. You never know where the connections are going to take you. You never know who's going to be able to help you years from now. I know this is one of the reasons why you need to be thinking who's going to write your letters of recommendation. You might have an opportunity that comes up in the next month or 2 or 3 that you weren't expecting, and you might need a recommendation quickly. You want professors who are able to speak up to you. So when you make comments in class, please email me. And again, I know some of them may not seem that mathematical, knowing that 2, 4, 6, or 1 is Jean Valjean, but I really want you to get comfortable speaking up and getting to know you. I am happy to take people out for lunch or for coffee, smoothies, whatever, or just go for a walk. If you are not on campus, I'll carry my phone and do it like that. If you want to do it in small groups, that's fine. But you are at Williams College. We are at least open for business. We at least have the option for students to be here. Take advantage as much as you can. Try to get to know the people here. All right, so just going back to the mechanics. So again, I will assume everybody is going to take advantage of 60% of their grade being on the boundary of an AA minus. You still have to pass the final, but the goal is I really want to take off the pressure. If you work hard, you should be fine in terms of the material. Now, in the first section, we talked a little bit about what does it mean for a function to be differentiable, and that there's going to be a lot of differences between 1 dimension and 2 dimensions. And so does anybody want to tell me what it means for a function for a limit to exist in 1 dimension? So what does it mean for a limit to exist in 1 dimension? Sadly, the pen is still not working. So if I want to approach 0, how can I approach this in 1 dimension? What are the ways I could approach this point?
From the left or right?
From the left and from the right. Is there anything else I can really do? No. Limits in 1 dimension are boring. All right, let's look at 2 dimensions. And I really tested the pen right before class and it really worked then. All right, how can I approach the limit in 2 dimensions?
From the top and bottom.
So I could come from the bottom. So that's one way. Any other ways?
From the left and right.
From the left and right. Any other ways?
Could also go diagonally.
Go diagonally, infinitely many lines. I could go quadratically. I could choose a logarithmic spiral. Or my personal favorite, I could do the scribble. Right? And so if you've ever seen Karate Kid 2, that's where he goes to Japan and they learn the secret of Miyagi karate. This is the secret of multivariable calculus. That in 1 dimension, it's kind of boring to approach a point. You only have 2 options. In multivariable calculus, you have to do something that will work for all these paths. We will do proofs in this class. I will not hold you responsible for proofs on exam, but we will do proofs in class and we will talk about what is needed to make things rigorous. And there are some subtleties, there are some difficulties. The subject has to handle all paths like this. When I first taught this class at Williams, my kids were in the Children's Center and everybody got their own individual scribble. This is what I want you to think of. It takes less than a minute to teach you how to do multivariable differentiation. It takes a little bit longer to teach when it's valid. When is the function differentiable? My brother is an engineer, and he says, but why do you care about all this stuff? All the functions we look at in the real world are going to be nice. Most of the time that is the case, but there will be exceptions. There will be situations where it is false. And so this is the first day of class. It's right after claiming Williams. And there are many valuable lessons You may think it's a little strange to be talking about this in a math class. Isn't math, pure and objective? There are biases everywhere, including in math classes. Mathematics comes from mathematicians who live in the real world, who choose axioms. I'm going to send you a short scientific article by one of my favorite authors, Isaac Asimov, on Euclid's fifth postulate, and just how easy it is to have biases and assumptions and not to be aware of them, and to be afraid to go against the conventional wisdom. And so I really want this to be on everyone's radar about how easy it is to do this and why we have to be careful, why we have to be rigorous, that these things have to be justified. We will not justify everything. And if I have a choice between doing a long technical notation-heavy multivariable calculus proof or a shorter, simpler Calc 1, Calc 2 proof that highlights the key ideas, yeah, this is a no-brainer. I'll do the Calc 1, Calc 2 proof and just talk about, if you really want to, you can make this rigorous. I'm happy to talk to you, but for the most part, I'm just content to do the Calc 1, Calc 2. But I want you to be aware of what needs to be done. Any questions so far? Okay, so I've talked about homework. Homework is due at the start of the class. Late homework is not accepted. If something is coming up, try to let me know at least a day in advance. I know that's a little bit hard with homework because homework is due most classes. It's for a variety of reasons. The most important is math builds on math, especially in a class like this. And so if there is a gap and you wait too long to cover it, it's going to snowball. And so the homework assignments are not meant to be strenuous. They're not meant to be too time intensive. As I said, this hopefully will be TAs available hopefully once, if not twice every day. You can also email me anytime. But I want you to get constant feedback. Homework will be graded and returned by the next class. It's only 15% of your grade, and if you're doing the 60% option, it's only 40% of 15%. All homework problems are worth the same amount of points. They're worth 10 points each. Please write neatly. Please make sure that if you are scanning it and you're taking pictures, that you have good lighting. Someday you too may be a grader and you might want people to be able to read. You might want to be able to read what they're sending you. So please be considerate of the graders when you are doing things. If you want to type things up, that's absolutely fine. If you want to have a stylus that works, you're welcome to do that. All right, so any questions on the course mechanics?
Can we hand in our homework in person too, or are we always going to submit it?
I don't know. I have to investigate as to whether or not homework can be handed in person. My feeling is, with the way we like to do all of these mitigation strategies, I think they want to minimize any interaction as much as possible. One of the things we talked about in section 1 was the geometric series formula. There is a way to prove this by shooting hoops and playing a basketball game. And when I teach multivariable calculus, I actually bring a basketball hoop and balls to class. What I will have to do this time is I will bring 2 basketballs so that if we do this, no one is touching a ball touched by someone else. So for now, I think we have to assume that all homework is going to be scanned and submitted through Glow. If that is a problem for anyone, let me know and I will try to find a way to have it handed in person. Any other questions on the mechanics? And also, the mechanics now could be very different in 1 month. As times change, as we adjust to the new normal, as more people get vaccinated. But right now, with students coming back to campus and you all starting off in quarantine, we are being especially cautious. Normally, I have a no cell phone policy. If your cell phone goes off, it's an automatic quiz for the entire class. I will not have the cell phone policy this year. If you are remote and I am not seeing the comment you're putting in, feel free to call somebody in class and just have them pass on the message. All right, so general syllabus information. We're going to cover most of chapters 11, 12, and 13, as well as some stuff on sequences and series. The semester is going to start off looking anything but a calculus class. We're going to be doing vectors and notation. And the reason is we need to learn the language. Before we learn the language, we cannot play multivariable calculus. Any Star Trek fans in the class? All right. Have you seen the original Star Trek series?
I've watched like some episodes, but never like the whole thing.
Okay. So let me see if I can quickly pull up a picture. Here we go. Excellent. All right, so the first picture I found is not with Captain Kirk, but it's fine. It's with a spoiled brat who gets upset when he loses. It's wonderful. So it's not letting me cut and paste today either. So it's just one of those days. So this will just take an extra second, not a huge deal. All right. So let me go back, switch, share. Bye. Oops. Here we go. All right, so can people see the 3D chess game? Looks cool. So I actually bought this so that we can play if anybody wants to. When they created it for Star Trek, what do you think they created? They just created the board and they took standard pieces and put the standard pieces on the board. They had absolutely no rules for the game. They just had people moving things in ways that looked cool. Years later, after the fact, several geeks got involved and they came up with entire sets of rules for how to play. And so there's a lot of fascinating stuff here. The reason I'm bringing this up is I bought this, so if anybody wants to learn how to play, happy to teach. My kids and I tried to figure it out. They included a instruction manual for the game, and we could not figure out exactly what was going on from reading this. It was not clear, it was not well written. What do you do in a situation like this? You want to figure out how to play, but I can't understand the rules in the package they gave me. What should I do? This is 21st century America. What do you do when you don't know something?
You look it up on the internet.
You look it up on the internet. And so very quickly, I found a bunch of different sites that had how to play 3D chess. They don't all have the same rules, but okay, they were mostly the same. Why am I bringing this up? Well, we started by talking about we're going to spend the first quarter of the semester on notation. A couple of them had games where they had, here's a set of moves for a game. All of these moves are legal. Good, if I see a legal game, I can then try to deduce how to move the pieces by seeing what's legal and get at least some information. In order to do that, you need notation. And so before we could even understand how the game was played, we had to understand the notation of how do you move pieces in the board, how do you denote pieces in the board. It was a major advance when Descartes came up with the coordinate system, and we're going to represent points with X and Y coordinates. We still call this the Cartesian axis in his honor. And so it takes a while to understand the notation for 3D chess, because there are some squares that are non-existent, but you can use them, but you can only use the non-existent squares in certain ways. You are allowed to move some of the subboards to different parts. So if you look very closely, there's actually a little board here that's connected. And if the board is, depending on who you go to, either empty or has only one piece on it and that piece is yours, you can move that board to another part of the main board. You can flip it over. You need ways to denote all these different types of moves. And so it took a while to learn the notation. Once we learned the notation, then we could understand the game. We need to do that here in multivariable calculus. We need to learn the notation, and the notation is vector analysis. Once we learn that, we're going to be in great shape. So So that will be the beginning of the semester. We will be learning some stuff here. So this is a wonderful chance for you to review your your single variable calculus. Does anybody want to tell me which integration technique is their least favorite?
Integration by parts.
So you are welcome to say that, but I think there's something you hate more than integration by parts. You might hate it so
Trig
much
substitution.
you blocked it out from your memory.
Partial fractions.
Partial fractions. Now, it's perfectly fine if integration by parts is your least favorite, but most people, oh yes, I had forgotten about integration by parts. Yes, that is my least favorite technique to use. I will not be doing integration by parts. For the most part, I will not be doing trig substitution. I will be doing, for the most part, partial fractions. I will not do, and I will not do trig substitutions. I will do some U substitution. I will do some integration by parts. My goal is not to try to trick you with very difficult, painful Calc 1, Calc 2 derivatives and integrals. I want to choose simpler functions to highlight the multivariable calculus concepts. And again, for a lot of these problems, all that happens is if you use harder functions, it's just more work. It's not fundamentally difficult, more challenging. It's just you have to do a little bit more calculus. So I want to choose things that really highlight the multivariable calculus. So no derivatives of sines, cosines. You should know the derivative of tangent, but you can remember tangent is sine over cosine, so I can rederive it if I forget. We're not going to be doing much calculus in the beginning of the semester, so this is a great chance to use the resources on the web page or to go to the tutors for the class and just say, hey, I'm a little rusty on derivatives, can you help? There's a big handout problem where I have a bunch of problems from Calc 1 and Calc 2 with solutions. I strongly urge you to spend some time going through that right now. If you have questions, contact the TAs, contact me, always happy to chat. And again, class is going to be more productive if you tell me what you want done. It makes no difference to me what we cover. I know multivariable calculus. I have been teaching multivariable calculus since before you were born. Okay, it should be easy for me. I should not have to prepare much for classes. If so, you're not getting your money's worth. It's going to look very easy for me because I've been doing it for so long. If there are things that you are confused on, look at what homework is due before class. Okay, we're going to do section 11.3, and I'm going to assign, say, problems 2, 3, 5, and 7. I seem to like the prime numbers. Hey, Professor Miller, could you go over problem 6 in class? Sure. And we can use class time to go over problems. Or, Professor Miller, I was trying to understand the proof of law of cosines, and I just don't follow what you were doing. So when I was a freshman, I was taking an advanced math class, and my friends and I were having trouble with one of the problems. So we went to one of the science tutors. And the explanation he gave was extremely valuable. So anybody know which college football team finished second in the nation this year? I was a postdoc there for 1 year.
Was it Clemson?
It was not Clemson. This was the school that beat Clemson. By now, you should have been able to discreetly Google it.
Is it Notre Dame?
No, it was not Notre Dame. Notre Dame had their bank ripped by Alabama. It's the Buckeyes. Anybody know what school is the Buckeyes?
Ohio State.
What is the full name of Ohio State? It is the Ohio State University. We do not talk about the proof in a math class. We talk about a proof. There's more than one way to do things. And so when I went to the tutor, he said, oh yeah, boom, 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 boom. And we looked at the tutor and said, yeah, we don't understand the words you used. He goes, oh, okay. What about the following? Okay, we understand most of the words now, but we still don't follow your proof. Okay, let me think for a bit. And you thought for about 20 seconds, all right, well, what about the following? Adding, subtract. Yes, we can understand this proof. And so just because something is presented one way does not mean it is the only way to present. So from a mathematician's perspective, who is the most influential US president? Anybody know? As Williams students, you should know the name of this president. The only Williams alum to become a president to date.
Garfield.
Garfield. He is credited with an original proof of the Pythagorean theorem. You may argue that his proof looks suspiciously similar to the trapezoidal proof, but as a Williams professor, I will not so argue. And he is credited with a proof. There are hundreds of proofs of the Pythagorean theorem. Different proofs highlight different facts, and they're valuable for different things. And they will generalize in different ways. And so again, when we're doing a class like this, if something doesn't connect with you, by all means, try to find it another way. And again, I'm happy to try to come up with another approach. So I did mention for cultural extra credit, in the first class, I had asked which animated movie from the last 5 years has a villain who has a Rubik's Cube. And so I'm hoping that there will be some intersection between my cultural references and my kids' cultural references and you. So the hint is it's from the Despicable Me universe. Any Despicable Me fans here? I'm just trying to get a sense of what cultural experiences do we have in common.
Is it Vector?
No, Vector's the first movie. The villain in the third movie has not really gotten over the fact that the 80s have ended. And you do see Rubik's Cubes on his evil lair at the end of the film. All right, so one of the other things we talked about in the first class was the difference between necessary and sufficient conditions. And so, the geometric series, 1 plus x squared plus x cubed, et cetera, it equals 1 over 1 minus x, if the absolute value of x is less than 1. If the absolute value of x is not less than 1, we can't use this formula. Does anybody know a necessary condition that may not be sufficient for winning the Super Bowl? So necessary has to happen, sufficient suffices. So over here, if we want our function to be differentiable, it's necessary that the derivatives exist as we approach along the axes, but that's not sufficient. You must be differentiable along any path. Anybody have a thought about what might be a sufficient condition, a necessary condition for winning the Super Bowl?
That you win the playoff game leading up to it.
You win the playoff game leading up to it. So if you have not won the conference championship, you cannot win the Super Bowl. In section 1, we had, you must be in the Super Bowl. Can somebody give me a sufficient condition to win the Super Bowl?
Winning the final game.
Winning the final game, scoring more points than your opponent. That is a sufficient condition. Can you say having Tom Brady as your quarterback is a sufficient condition? No, there's years he's lost the Super Bowl. So it's an interesting question as to what would be sufficient conditions. And for the Super Bowl, it's pretty clear, scoring more points than the opponent. Somebody said in the first condition that in the first class, that a necessary condition is having enough players. I'm not sure if that's a necessary condition. In a lot of sports, they don't let you play if you don't have enough players. I know in football, you can get a penalty if you have too many players on the field. I don't know if they will let you run the play if you have too few players. Anybody familiar enough to know? So something that can be searched, can you actually run a play with only 10 people on the field? I don't know. So we will spend a lot of time talking about necessary and sufficient conditions in the class. Obviously, we love sufficient conditions because if that holds, then we know we're done. Frequently, though, it's much easier to find necessary conditions. Okay. Any other questions on mechanics or things we've done up till now?
This is just a question on the syllabus. Do you have like
Yeah.
a rough for the midterms?
Let me see. So if I look at previous classes, that might give me a rough sense. I mean, basically, when we finish chapter 11, that's when we will have the first midterm. And so I'm just looking right now for the articles and videos as to when we finish chapter 11. So it looks like so we've got the chain rule on the 11th class. So the 11th class is already going to be differentiation. 10th class looks like it's differentiation. 8th class differentiation. Derivatives on the 7th class. So maybe after the 6th class, roughly, I might guess is when we would have enough for the first midterm. And again, I will drop your lowest midterm. So if you do well in the first midterm, that's great. But it's really meant to be diagnostic, to get a sense of how well do you remember your Calc 1, Calc 2. I think some derivatives are on the exam. No integrals yet. I will be asking you constantly to define things, to state theorems, to know definitions. It's extremely important for you to be able to talk about the objects. And this is very similar to the notation from 3D chess. And if we don't have good notation, it's going to be very hard to discuss something. There is more than one way to have notation. Do we have any chess plays in class? So you can have extremely concise notation if you want. I am not a fan of extremely concise notation. So the great Richard Feynman reduced all of physics to one equation. If you can solve this one equation, you understand all of physics. Not bad. Anybody want to see the one equation that all of physics reduces to? The answer is, of course, Professor, we're very excited. U equals 0. And seeing this, what question do you have?
What does U stand for?
What does U stand for? Excellent question. So U is going to be basically F minus MA squared plus E minus MC squared. Anybody notice what I'm doing? I'm just writing down all the equations in physics. I'm subtracting the left from the right, I'm squaring, and I'm adding them. What's the only way that sum can be 0?
For every equation to be 0.
If every equation is 0. So I have reduced all of physics to one equation. Have I done anything by doing this? Is there any gain in this? Absolutely not. When we choose notation, we want notation that is good, that is useful, that is helpful, that we can just look at it and understand what's going on. What notation do we use in calculus? We often have little f for a function, and what is big F? In calculus, if you have little f, what is typically the relationship between big F and little f?
The derivative of big F is little f.
Yeah, so typically the derivative of big F is little f. It's a antiderivative. And the advantage is I can quickly look down and see what's going on. in calculus, I might write the integral from 3 to 4 of f of x dx. And this is the area under the curve from 3 to 4. I could add x equals 3 to 4. Is there any need to write x equals? Not in one-dimensional calculus, because there's only one variable in play. But in multivariable calculus, when there's several variables, I like to write x equals so that I can quickly glance down and see what is this integral about. And so I will often choose more cumbersome notation than shorter, cleaner, concise notation, because the goal is to understand what's going on. All right, so I'm going to stop the recording.